Got to recharge my batteries. Getting all these Unit 7 things done. Whoa, there we go. 7.8. All right, kids, my name is Mr. Krause. All of this stuff can be found at www.nknewmankrausseinfinity.com. And you can see my partner in crime, Miss Vicky Newman. My name is Mr. Krause, but for a little while, you're going to call me Mr. Key. Let's get going on this stuff. Graphing the cosine function. So we just spent a day and a half or 2 days graphing the sine function. Cosine function looks and feels and acts a lot like the sine function, but it's only got a phase shift off. It's sort of a phase shift off. What? It's a little shifty off. It's shifty. Oh, it's a little shifty. The cosine function's a little shifty. I don't think anybody understands what little shifty means. First thing I asked you to do is to create or to get through this warm-up. All right, so quadrantal angles, first of all, you should probably know and be very familiar with those. Those are 0, 90, 180, 270, and 360. Let's see, 1, 0. 0, 1, negative 1, 0, and 0, negative 1. And remember, we're dealing with cosine now, so cosine is going to be the x values. All right, we did the same exercise yesterday, or 2 days ago, or an hour ago, depending on what you did. All right, so now we're going to deal with this again. Cosine to 30 degrees. Again, practice with your fingers a little bit, kids. 30 degrees. We're going to put down what? We're going to put down this. 3, 1. Square root of 3 over 2, 1/2. Now 30 degrees again, but they're all going to be that. The square root of 3 over 2, 1/2. We talked about this yesterday, or 2 days ago. I don't remember. I think we did this one 2 days ago. Square root of 3 over 2, 1/2. But the only difference is going to be is whether or not we have sines. In the second quadrant, cosine's negative. In the third quadrant, both are negative, and in the fourth quadrant, this one's negative. All right, 45 degrees. That gets old when I do that, like, but I like doing it. I don't know why. In my brain, I just have to do it. All right, 45 degrees. Put down the middle finger. Oh, 2 and 2. Square root of 2 over 2. Square root of 2 over 2. They're all going to be that. The only difference is in the quadrants are going to be the sines. In the second quadrant, again, cosine's negative, both negative in the third quadrant, and only the y is negative in the fourth. And finally, 60 degrees. Now for 60 degrees, you put down the ring finger. That's why I kept my ring on in that video. Take the ring down. You got 1 and 3. 1 over 2, square root of 3 over 2. So 1/2. Square root of 3 over 2. 1/2. So by now, this stuff should be old hat. And negative, both negative, and only the y is negative. So how'd you do? Pretty good? Again, when you're graphing, we're only going to work in radians. Now, you can graph, and I'll show you again. We'll do the graph in trigs, but just generally when we're working with these, you got to be comfortable with the idea of these new units of measures called radians. So let's talk about the quadrantal angles. I'm just going to highlight the quadrantal angles. That's 0 and 360. That's 180. That's 0, 380, 360, 180, and 0. So the cosine of 0 from above is 1. The cosine of pi, or 180 degrees, is negative 1. The cosine of 2 pi is 1. The cosine of 0 is 1. The cosine of negative pi is negative 1. And this is 1. Now let's talk about the other quadrantal angles. 90 degrees. 180 and 270. Excuse me, 270 and 90. 90 and 270. So, at all of those, we're going to have zeros. At all of those. what do I mean by that? What do I mean by all of those? If I go left 90 and left 180, excuse me, if I go standard position 90, 180, or 90, 270, both the x values are 0. If I go standard position counterclockwise and stop here, zeros and 0. So all the quadrantal angles above 90 and 270 will be 0. 180 and 0 will be 1. Now in between, just like with the sine function, at all the 45 degrees, and I'm just going to put 0.7. You know it's 0.70, 0.7071, but the graph, we really only need 0.7. But you got to remember what quadrant in. Now I got to remember what quadrant I'm in. First quadrant, second quadrant, cosine's negative. Third quadrant, everything's negative in the third quadrant. And in the fourth quadrant, cosine's positive. All right, so we're good with that. I think I just messed that up. I totally messed it up. I messed that up yesterday, I think, too. I'm going to have to fix that. Maybe I'll fix it, maybe I won't. Because this is the first quadrant. This is the second quadrant. This is the third quadrant. This should be negative. Second quadrant, third quadrant. This is actually the fourth quadrant. I always forget we're going negative pi. This is the fourth quadrant, so this is actually positive. This is the second quadrant, which is negative. Gummit. Negative, and then, so this is the fourth quadrant, positive. This is the second quadrant. The third quadrant, negative. This is the second quadrant, negative, and then this is positive. Okay, whew. Anyway, let's get over to graph this thing. I don't want to mess that up any longer. It should be pretty easy to graph. Here's what I want you to remember. Here's what I want you to keep in your brain when you're graphing the trig function or the sine. Why do they say sine? Oh, daggone it. On my corrected version, they say cosine. They should say cosine x. I don't know why. I mean, on my printed version, they say cosine, but here they say sine. I don't know why. Maybe that's what I got confused by. I'm sorry, kids. They're both cosine. We're graphing cosine. So, yeah, we're graphing cosine. Interesting. Anyway, at 0, we're at 1. At 2 pi, we're also at 1. In between these two, for cosine, we are at a minimum, -1. And in between those, we will have our zeros at pi over 2 and 3 pi over 2. So notice on cosine, we have 3 points that will be max and mins, 2 zeros. On the sine, we'll have 3 points that will be zeros, and in between those, we'll have max and mins. So we got a little bit of a difference. Let me graph this thing. Now, at first, it looks almost completely different than, don't forget right here, at pi over 4, we're at 0.7. At 3 pi over 4, we're at -7. Didn't put that in there. At 5 pi over 4, we're at -7. There we go. At 7 pi over 4, we should be at +7 because that's the fourth quadrant. Now, why do I only have 3 quadrants here? I probably shouldn't have done this. This is the first, the second, the third, and the fourth. Whew, man, what a mess. Anyway, let's go backwards. We'll do the same thing backwards. It starts at a max, ends at a max, min in the middle. Oops, min in the middle. In between those, we'll have our zeros. Now, if I graph, now you're going to say it's starting, except for my horrible graphing ability, it's starting to look like the sine curve. But the sine curve starts here and goes up and down and back up. So that's why I said cosine's a little shifty, because it just got shifted over just a little bit. But it's the cosine curve. Now, is this a function? Yes, it's a function. What is its domain? Its domain is, for this one, is just negative 2 pi to 2 pi, because that's all we graph. In general, the domain for a cosine function is negative infinity to positive infinity, just like the sine function. The range, in this case, negative 1 to positive 1. Is it a one-to-one function? Well, no. It fails the vertical line test, or the horizontal line test, over and over again. But can I restrict it to a certain area so that it will pass it, and I can get an inverse that is, in fact, a function? And if I just graph this piece right here, then that would be a function. So I'm going to graph from 0 to pi. The inverse on the next page, and its inverse will, in fact, be a function. So just like before, in order to find the inverse, we're going to switch the x and y from what we did previously. So my y's are going to become my x's. Now we're only going to use we're only going to use between 0 and pi. So let me erase all of this. We're only going to be using between 0 and pi. So at 1, it's 0. At 0.7, it's pi over 4. At 0, it's pi over 2. At negative 0.7, it's 3 pi over 4. Forgot where I was going. And at negative 1, it's 0. So 1, 0. 0.4, 0.7 pi fourths, 0 pi halves, negative 0.7, 3 pi over 4, and negative 1, not 0, this should be pi, negative 1 pi. So there's my graph of the inverse of this. Now, again, if I took this thing, let me see if I can show you what I've done. If I just take this piece, this black piece I've got right here, and I reflect it over the line y equals x, which is kind of hard to see right now, but reflect this over the line y equals x. This point comes up, and because the units are going to change, this point's going to come up here, this point's going to go down here, and it's going to go over here, and it's going to look something like that. Well, it kind of looks like a reflection. The only reason it's not exactly look like that is it doesn't look exactly like that is because of the units are a little weird. Once again, there's two ways to write inverse cosine. We can write cosine negative 1 of x, as we've done in the past, or we can write arc cosine. They mean the same thing, and sometimes they like to surprise you by putting arc cosine in there or cosine negative 1. All right, we did this before. We did this on the sine curve, so we're going to move through this pretty quickly. Start at a max, end at a max, min in the middle, 0 and 0. That's how the cosine curve is done. Same thing if we're using radians. It doesn't matter. Start at a max, end at a max, min in the middle, zeros in between that, and graph a nice smooth curve. All right. And then these, you should be able to fill these in rather quickly. The cosine of 90 is equal to 0, just based on the graph. Cosine of 180 is negative 1. The cosine of 0 is 1. The cosine of 270 is 0. The cosine of 3 pi over 2 is 0. The cosine of 2 pi, just based on the graph, is 1. the cosine of pi over 2. I mean, just take a look. Pi over 2, cosine 0. Cosine of pi, -1. That's simple stuff. You guys can handle that. So let's graph this thing one more quick time. I'm just trying to get you practice by asking you to graph this over and over again. I'm just trying to get you some practice graphing it. It starts at a max, it ends at a max, and it's got a min in between. And in between those, we got zeros. So for what values does cosine equal 0? Okay, it equals 0 at 90 and 270. If I said that in, if I said that in radians, I would say pi over 2 and 3 pi over 2. When does it equal 1? Well, it equals 1 here and here. So notice it says equal to 360. Sometimes it doesn't have an equal to C360 because they like to trick kids. So 0 and 360 degrees. Or if I did in radians, 0 and 2 pi. And finally, when does it equal -1? Down here at 180 degrees. If I wanted to, I could just say pi. All right, characteristics of the cosine curve. You'll notice we're going through this much quicker with the cosine curve because it's very similar than what we've already done with the sine curve. The number in front, just like with sine, is going to be our amplitude. So, the blue curve, this is blue. This is red. And the black curve is the regular one. How do I find amplitude without equation? No difference. Amplitude is equal to the absolute value of the max minus min over 2. I don't know why I have to do absolute value. Oh, well, amplitude is always, always, always positive because it describes the distance it travels up. What does the letter in front of the x mean? Well, remind yourself that is the frequency. That is the number of times the curve, the full cosine curve, exists in 2 pi. In this case, in the irregular one, which is the black one, it's once. In the blue one, it only goes a half of a time, which is why there's a half here. And if you look at the red one, it goes twice. The full curve begins, here's 1, here's 2. Period. Remind yourself, period is equal to 2 pi over b, where this is our b value. And our scale, it's always going to be 2 pi over period. Excuse me. Period, I don't know what I was just doing. Period divided by 4. Because remember, when I graph this thing, I want 4 points. So if you take a look at the black one, we'll always start at 0, and I want 4 other points. Once, twice, 3 times, 4 times. The same with the sine and cosine. I want 0, I want 90, I want 180, I want 270, and I want 360. So I need 5 points in order to graph this curve. We start at 0, so I need 4 other points that I'm going to get. Now sometimes they're not these to get on the regular curve, no transformation, it's going to be those. And finally, should come as no surprise to you, the adding and subtracting on the end, all it does is move the cosine curve up and down, just like it did on the sine curve. And to find the max, or to find the min, it's C minus A, and to find the max, it's C plus A. That's it. So let's practice. Not much different than what we did before. We've already done this stuff. We're just now going to do it with the cosine curve. Trying to see what I got left to do. Oh, a couple pages. Okay, so amplitude is, let's put some scale. Let's put here 1, 2, -1, -2, pi over 2, pi, 3 pi over 2, and 2 pi. So we're always going to graph to 2 pi. Not always. Sometimes I'll ask you to graph from negative pi to pi. Sometimes I'll ask you some crazy things. But, for now, when we get to the next couple days, we'll do some different things. So our amplitude is A. Our B value is 1. Remember, period is 2 pi over B, which is 1, so that's just 2 pi. And remember, scale is just 2 pi over 4, which is pi over 2. And I'll talk again about what that scale means and how we get that there. Now, scale, normally what we used to do is just say, hey, we're going to put our scale here. But this scale is going to give us where all the 5 points are going to be. So in this case, I'm going to only have 5. I'm going to have the 5 main ones, no changes. C is plus 1. My min is 1 minus 2, which is negative 1. My max is 1 plus 2, which is 3. Just like before, we started our midline, which is 1. Draw a dotted line. And then we're going to graph it. Now, to graph it, you start at a max, which we said was 3. We're going to end at a max, and we're only getting one curve in, so that's where our max is. This is going to tell us where our second max is going to go. And in between those two is a min. Now, the min is at negative 1. So in between those, you're going to go to a min, which is negative 1. This distance has to be the same as this distance. So make sure that's true. Okay? Because that's your amplitude. And then in between those two are going to be zeros. Tis done. A is 2. A is not 2. I was looking at the wrong number. I was looking at example 2. A is 1. B is 2. Period is 2 pi over 2, which is pi, which means we're going to get 2 full curves in. Now, the scale factor, which is going to be pi over 4, means every pi over 4, we're going to have one of our important points. So every pi over 4, we need to have an important point. C is negative 1. Negative 1 minus 1 equals negative 2. Negative 1 plus 1 equals 0. There's our min and max. 1, 2, negative 1, negative 2, pi over 2. Pi, 3 pi over 2, and 2 pi. All right, so let's get through this. Go grab purple. All right, we need, now, this is where our ending max point is. Our beginning max point is going to be at 0. Whoa, 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 let's back up the crazy train, Krause. You forgot to put in your midline. Put the midline in. All right, now we're going to put in all of our points. We'll start at a max. We're going to end at a max. Now, why am I ending at a max there? Because I need to finish one full curve in pi. So in between those is going to be a min. And in between those are going to be our zeros. Well, notice that's at pi over 4, an important point. Every pi over 4, we're going to get an important point. All right, but I'm not done because now I got to go again. Max, max, min. In between those are going to be some zeros. Perfect. Notice it's 2 full curves in 2 pi. Right? All right, here we go. Let's do another one. Amplitude is 1/2. Period is 4. Excuse me, B is 4. Frequency, that means 4 curves in 2 pi. Period is 2 pi over 4, which is pi over 2. That means we're going to have, it's going to end, its first curve is going to end at pi over 2. Everything's getting xylophoned and cramped in. Scale is pi over 2 divided by 4, which is really pi over 8. That means every pi over 8 is going to be an important point. We're going to cram this thing in, kids. We're going up 2. 2 minus 1/2 equals 1.5. And 2 plus a half equals 2.5. Does this sound familiar? We've done this before. It's the same thing we did yesterday with the sign. 1, 2, 3, negative 1, pi over 2, pi, 3 pi over 2, 2 pi. Let's get our midline in. Midline in is in at 2. There's our midline. All right. So we're going to start at a max and end at a max. What's our max? 2.5. Start at a max. End at a max. Wait a second. I got to get a full cosine curve into that? Yeah. Because remember, we're going to end our first curve. Remember, period is the distance it takes to finish one full curve. So it's pi over 2. Well, in between those two, then I got to go to a min. And in between those two, I got to go to zeros. One full curve. Got to do another one. That was awful. One full curve, two full curves, three full curves, four full curves in 2 pi. Someday I gotta stop drinking coffee. It's probably gonna hurt me someday. Amplitude is 3. There it is, right in front. My B value is 1. What does that mean? One full curve in 2 pi. So that means I'm just going to have one curve. That's going to be a lot nicer than that last one, because that last one was kind of a pain. So that means my period is 2 pi over 1, or just 2 pi. That means we're going to start with a max and end at a max at 2 pi. My scale factor is just 2 pi over 4, which is really pi over 2. 1, 2, 3, negative 1, negative 2, negative 3, pi over 2, pi, 3 pi over 2, and 2 pi. All right, need our C value. Our C value is our midline, which is at negative 2. Negative 2 plus 3 is equal to 1. Negative 2 minus 3 is equal to negative 5. Min and max. All right, start with our midline. Always start with the midline, which is at negative 2. Ooh. Well, that's weird. I'm not going to get to negative 5 on this one. Thought I got to negative 5 yesterday. Oh, the graphs are different. All right, we'll get there eventually. I'm going to fake it on this one. Normally I wouldn't fake it, but the graphs you have hopefully have the right graphs here. I don't know what's going on with these. I don't know where these ones came from. The graphs on my note sheets are fine. So I'm going to start at a max, which is at 1. I'm going to end at a max, which is at 1. And in the middle, I'm going to go to a min. Well, the min should be down here. There should be an extra line right here. You normally cannot do this by adding in the graph. You have to change your scale. In between those, we'll go zeros. There she is, kids. I don't know what happened there. Oh, now we're going to work backwards. Now I'm going to give you a function for these 4, and you got to write the equation. So I help you with it. I help you with it. What's my midline? Okay, let's go midline. Midline is right there. That's at a half. What's my amplitude? Wait, that's not the midline. What am I, crazy? The midline, okay, the midline is between the max and the min. So unlike the sine curve, which you can just follow the points, this is actually my midline. So I have full curve, half above, half below. So what midline is just 0. The amplitude is up only, looks like about a half. That's where I want to put the half. The period, how long did it take to finish one full curve? It took 2 pi. What's my frequency? How many curves did it finish in 2 pi? 1. So my equation is y equals 1/2 cosine of x. That's it. All right, let's move. Halfway between here, top and bottom. Here's the bottom. Here's the top. There, my midline is 0 again. My amplitude is how high did I go up? I went up 1. My period, it took 2 pi to finish. And my frequency is 1. It only finished 1. Now, the only difference with this one is y equals, my amplitude is 1, so that's cosine. I don't need to put a number there. My frequency is 1, so I just put an x. So this is really just the cosine curve, but it's backwards. It's upside down. So therefore, it had a reflection in it. Just like before, you put the negative out there for the reflection. All right, this one's a little trickier. Midline. Here's my max. Here's my min. So there's my midline right there at -1. Amplitude. Up 1, down 1. 1. Period. All right, how long would it take this sucker to finish going? Oh, it would take 4 pi. How much of the cosine curve did it finish in 2 pi? That's the frequency. It only finished half. So my equation is y equals 1 cosine 1/2 x, because we only finished half the curve, and it moved down 1. All right, and finally, the last one. Let's see, the max is at 1. The min is at -3, so right here would be the middle, right? -1's the middle. Amplitude is 2. How long did it take to finish 1 full curve? Pi. That's the period. How many did it finish in 2 pi? Oh, that's 2. So remember, this is our B value, this is our A value, and this is our C value. So y equals cosine. Oh, excuse me, we have an amplitude. Y equals 2 cosine. We have a B value, 2x, and we have a C value, -1. That's it, kids. That's the end of day 8. There are 9, 10, and 11. 3 days left, plus a review, and we're done with this unit. So keep working hard, keep asking questions, and persevere. Persevere. All right, kids, if you haven't hit the subscribe button, please do so. Catch you guys all on the flip side. Goodbye.